Let us start with the next topic in measures of dispersion, combined standard deviation. There are 3 steps to find combined standard deviation. Step 1, we have to calculate combined mean. Combined mean is denoted as xc bar, which is equal to n1 x1 bar plus n2 x2 bar by n1 plus n2. The second step, we have to calculate d1 and d2. d1 is the difference between combined mean and mean of the first group. D2 is the difference of combined mean and mean of the second group. In the final step, we have to calculate combined standard deviation, which is equal to root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square by n1 plus n2. So please pause the video and take down these 3 steps so that when we do the sums, you can understand better. So I hope you have copied the formulas. Let us look at the problem. The first question they have given, if 2 samples of size 30 and 20 have the mean as 55 and 60 and the variance as 16 and 25, what would be the combined standard deviation? First, let's write what is given in the question. So what has been given? The size of the group has been mentioned. What is N1? N1 is 30. What is N2? It is 20. What is the mean of the first group? X1 bar, which is equal to 55. And what is mean of the second group? X2 bar, which is equal to 60. Standard deviation is denoted as sigma. So variance is equal to standard deviation square. So variance is equal to sigma square. So variance of group 1 is denoted as sigma 1 square, which is equal to 16. And what is variance of group 2 denoted as sigma 2 square, which is 25. So now let us do the first step. First step, we have to calculate the combined mean. So combined mean is denoted as xc bar, which is equal to n1 x1 bar plus n2 x2 bar by n1 plus n2. So xc bar is equal to n1 30 into 55 plus n2 into x2 bar, which is 20 into 60 divided by n1 plus n2, 30 plus 20, which is 50. So calculate this value. What are you getting? Are you getting 57? Yes. So this is step 1 where we have calculated the combined mean. Now let us proceed with step 2. Step 2, we have to calculate D1 and D2. What is D1? D1 is the difference between combined mean and mean of the first group. So D1 is equal to 57 minus 55, which is nothing but 2. So while calculating the difference, we have to ignore the sign and only take the magnitude. So we'll do the bigger value minus smaller value. And what is D2? The difference between combined mean and mean of the second group. So we have to compute the difference between combined mean and mean of the second group. So since we want only the magnitude, let us do 60 minus 57, which is 3. So I'm calculating what is D1 square and D2 square as well. What is D1 square? 2 square, which is 4. And what will be D2 square? D2 square is 9. So that I can directly substitute in the formula. So I've calculated D1, D2, and I've calculated D1 square and D2 square as well. Now the final step, we're going to calculate the combined standard deviation. What's the formula for combined standard deviation? Root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square by n1 plus n2. So let us substitute all the values and get the answer. What is n1? n1 is 30, sigma 1 square is 16, plus d1 square is 4, plus n2, 20 into sigma 2 square is 25, plus d2 square is 9, divided by n1 plus n2, which is 50. So for the numerator, we have to do 30 into 20 plus 20 into 34 we have to do. So if you do that, what are you getting? 30 into 20 plus 20 into 34. Are you getting 1280 divided by 50? So divide it and take root. What are you getting? So just divide 1280 divided by 50. What are you getting? 25.6. What is root of 25.6? Are you getting 5.06? So which option? Option B is the correct answer. Okay, so now let us see how to do correction in standard deviation. That's the next topic. How to calculate correction in standard deviation. Totally, there are 4 steps. Step 1, we have to find the correct value of summation x square. So for that, to find the correct value of summation x square, we have to calculate n into sigma square plus x bar square minus wrong observation square plus correct observation square. So this is the first step. Step 2, we have to find the correct value of summation x. So how to find the correct value of summation x? It is equal to n into x bar minus wrong observation plus correct observation. Third step, we have to find the correct value of mean, which is equal to correct summation x divided by n. And the final step, using all these correct values, we have to find standard deviation. Okay, so please take down these 4 steps. Pause the video and copy it down. Okay, so hope you have copied. Let us solve a question based on it. A student obtained mean and standard deviation of 100 observations as 40 and 5.1 respectively. He copied an observation as 50 instead of 40. What's the correct value of standard deviation? So let us write what is given in the question. So what is given in the question? So they are given it's 100 observations. So n is equal to 100. And what is the mean that the student calculated? X bar has been calculated by the student as 40. And what is the standard deviation that has been calculated by the student? It is 5.1. He copied it as 50 instead of 40. So 50 is the wrong observation. And what should have been the correct observation? It should have been a 40. So do you remember the first step? First step, we have to find the correct value of summation x square, which is equal to n into sigma square plus x bar square minus wrong observation square plus correct observation square. So let us do step 1. Step 1, let us find correct value of summation x square, which is equal to n into sigma square plus x bar square minus wrong observation square plus correct observation square. So what is n? 100. What is the sigma value? It's 5.1. So 5.1 the whole square. What is x bar square? 40 square. So mean is given as 40. Mean square will be 40 square. What was the wrong observation? 50. So we have to subtract its square and add the correct observation square. Correct observation is 40. So we have to add 40 square. So tell me, what are you getting? What is 5.1 the whole square? It is equal to 26.01. What is 40 square? 1600. Minus 50 square is 2500 plus 1600. So solve the bracket value first. Multiply with 100. Then subtract 2500 and add 1600. What value are you getting? Did you get 1,61,701? So this is step 1. So in step 1, we have calculated correct value of summation x square. Now let us do step 2. What's the formula for step 2? We have to find correct value of summation x using the formula nx bar minus wrong observation plus correct observation. So correct value of summation x is equal to nx bar minus wrong observation plus correct observation. So what is n? 100. What is x bar? 40. Minus wrong observation is 50 plus correct observation is 40. So do 4000 minus 50 plus 40. Are you getting 3990? So thus we have calculated the correct value of summation x also. Let us go to step 3. What is step 3? Step 3, we have to find the correct value of mean, which is equal to correct summation x by n. Step 3, we have to find correct mean value. What is correct mean value? We have to use correct summation divided by n. So what is the correct summation x? It is 3990 divided by 100. So it should have been a 39.9. Right? The correct mean should have been 39.9. So step 3 also we have calculated. Step 4, we have to find the correct value of standard deviation using all these correct values. So let us go to step 4. Step 4, correct value of sigma. What is standard deviation formula? Root of summation x square by n minus x bar the whole square. So what is the correct value of summation x square? It's 1,61,701 divided by number of observations, which is 100, minus mean the whole square. What is the mean value here? It's 39.9. What is the correct value of mean? 39.9. So x bar square means 39.9 whole square. So 39.9 into 39.9, I'm getting 1592.01. So calculate this, divide this by 100, do the subtraction and then take root. What are you getting? Are you getting root 25, which is nothing but 5? So which option should we choose? Option A is the correct answer. So correct value of standard deviation should have been 5.